Hello everyone, it's Miss Noor Safi again. Welcome back to the chemistry course for high school diploma, American high school diploma. In this chapter, we are going to talk about the most beloved chapter, which is organic chemistry. Actually, I love organic so much. More than the analytical chemistry or physical chemistry or biochemistry as well. Now, let me remind you first that we have already explained Chapter 1, Atomic Structure, Chapter 2, Bonding, Chapter 3, Solid and Liquid, Chapter 4, Gases, Chapter 5, the acid and bases, Chapter 6, Equilibrium and Reaction Rate, Chapter 7, we have done a redox reaction, and now we are on Chapter 8, which is Organic Chemistry. When we say organic, many things comes to your mind. Many things come to your mind. Because everything around us is organic substances, right? Everything inside your body is organic as well. Organic is the basic part, or let's say the basic science of chemistry. Let me tell you that this is very small chapter, which is very easy, and it contains simple informations. You, in American high school diploma, have only to know specific informations. You don't have to know more by details for this chapter. So it's going to be so easy, and take it for granted. When you finish this chapter and when you cover all the ideas, you are so ready to answer any question you have. When we say about organic chemistry, let me tell you first that I have something called hydrocarbons. Again, I have something called hydrocarbons. Let us first identify the hydrocarbons, teacher. Let us change the color. The hydrocarbons. What are hydrocarbons? When I say hydrogen and carbon, okay. What is hydrocarbons? Hydrocarbons are compounds that consist of hydrogen and carbon only, with some of specific functional groups that will be determined later on. So I have carbon and I have hydrogen. So I'm talking about covalent compounds, because the carbon and hydrogen, they form covalent bond. And I'm talking about different types of hydrocarbons. In the organic chemistry, you have to know the main three basic part of the hydrocarbons, which are alkanes, alkenes, and alkynes. Let's start with the alkanes. What are alkanes? Alkanes are hydrocarbons with single bond. They are all saturated. We don't have double bond between two carbon atoms. For example, if I have carbon, let us have a small example. Okay, I have carbon, and the bond between the carbon and carbon is single bond. This is called single bond, and for sure you have 1, 2, 3 hydrogens here, and you have 1, 2, 3 hydrogens here. Okay, now this is called saturated hydrocarbon, which is alkane. All the bonds between the carbon are single bond. So the hybridization between the carbon and carbon is sp3 to sp3 hybridization for the alkanes. Okay, now we have as well alkenes and we have alkynes. We are going to go back to this table to cover it. What is alkenes? Okay, I will go to alkenes. Alkenes are unsaturated hydrocarbons. The unsaturated hydrocarbons, the word unsaturated means that we have double bond between two carbon atoms. So, suppose that I have these two carbon atoms. I have double bond between two carbon atoms, and then I have to end with 4 bonds I have to end with 4 bonds around each carbon atom. So I will add 1, 2 hydrogens, and here I will add 1, 2 hydrogen. This is alkenes. Okay, so alkenes contains double bond. Okay, and we say that this is unsaturated hydrocarbon because it contains double bond. It contains the first one, which is single bond, which we call it sigma. The other one is double bond, we call it bi. And the hybridization of the alkenes sp2 for 2 carbon atoms. Moving to alkynes. Okay, moving to alkynes. Alkynes are hydrocarbons with a triple bond between 2 carbon atoms. So if I have carbon with carbon and here I have a triple bond, and then I have to end with only 1 hydrogen for each carbon atom, and this is called as well unsaturated hydrocarbon because I have triple bond. The first one is sigma, the other one is bi, and the other one is bi. This is called a triple bond. Now, and the hybridization between the carbon and carbon is sp only between the 2 carbon with the alkynes. Okay, so after knowing the main, let's say general formula of alkenes and alkynes, let us now write the general formula for the compounds. Now, alkenes have a general formula of CN. Please concentrate. This is really easy chapter. They have a general formula of CnH2n plus 2. Okay? For example, let's have a quick example. For example, I have, let's take, for example, 2 carbons. I have C2. H2 times 2 plus 2, so I have C2H4 plus 2, 6. So this is an example of alkane. So whenever you are given a specific compound like this one and you are asked if it is alkane, alkene or alkyne, you have to refer it back to its original, let's say, general formula, which says Cn and refers to the number of moles H2n plus n, which is the alkanes. Okay, let's take 3 carbons. If I have 3 carbons, I will end with C3H2 times 3, 6 plus 2, 8. Excellent. If I have 4 carbons, I will end with C4H. 4 times 2, 8 plus 2, 10, and these and so on. You can continue by doing this for the bigger number of carbons like 5 carbons, 6, 7, and 8, and so on. For the alkenes, as we said before, it has double bond. Now here we have the general formula is Cn. Okay, the general formula is CnH2n only without plus 2. So if I have, for example, here 2 carbons, I have 2 carbons, I will say C2H only 2 times 2, I will end with C2H4. So whenever you see C2H4, this is alkene. If you are given C2H4, you would start with the number of carbons, it is 2, and then you say 2 times 2, 4. Whenever you see the number of hydrogens are 4, so it is only alkene. When you see the number of hydrogens are 6, it means 4 plus 2, so you have a plus 2 in the alkane, so it is alkane. And let's have another example. For example, if I have 3 carbons, I will end with C3H, 2 times 3, 6 only. This is alkene. And if I have 4 carbons, I will end with C4H8, so this is alkene. Actually determining whether the compound was or this hydrocarbon was alkane, alkene, alkyne is the first step to solve any equation you have or any formula you have in the next upcoming examples. But for the alkynes, I have the general formula. Concentrate, please. It's CnH2n minus 2. Okay, so it's CnH2n minus 2. If you notice here, CnH2n is the basic, plus 2 alkane, without 2 as alkene, minus 2 alkyne. Then I will start with 2 carbons. Then I will say C2H 2 times 2 minus 2, I will say C2H4 minus 2, 2. So this is my alkyne, as we already drew a few minutes ahead. And then let's move to 4 carbons. Here I have 4 carbons. C4H. 2 times 4, 8, minus 2, 6. So this is my alkyne. And 4 carbons, if I will end with 4 carbons, this is 4 carbons. I will do 3 carbons. Sorry, we got, okay, let me put it down. Okay, teacher, here if I have 3 carbons, I will say it is C3H, 2 times 3, 6, minus 2, 4. So this is my alkyne. And 4 carbons, I will say C4H, 4 times 2, 8, minus 2, 6. So this is the alkyne. And you can continue writing the hydrocarbon for alkene, alkene, alkyne for 5, 6, 7, 8, 9, 10 carbons. I just want to tell you that I have alkane with 1 carbon, which is only CH4, okay, which is the first alkane, which is methane gas. But I don't have alkene starts with 1 carbon, teacher, because alkene, there is a double bond between 2 carbons. So the minimum amount of carbons in the alkenes are 2. And for the alkynes as well, I don't have 1 carbon. I have 2 carbons with a minimum number of the first alkyne, which is C2H2. After knowing the general formula, we have to know how to name the alkane, alkene, alkyne. Basically, you have to memorize the naming of the carbon, number of carbons. Now I have 10 carbons. Okay, I have 10 carbons. I will memorize the first 10 carbons basically. Have to name them. Do a rhythm, make a song, whatever, connect them between each other, but you have to name them. I have my 10 carbons. Let's start. Meth, eth, prob, but, bent, hex, hept, oct, non, dec. Again, meth, eth, prob, but, bent, hex, hept, oct, non, dec. Okay, these are the basic name of the carbon, number of carbons. I wrote here when I have only 1 carbon, it's meth, eth, prob, but, bent, hex, hept, oct, non, and dec. And then you say if it is alkane, so it is methane, ane, you add the section ane. If it is alkene, again, if it is alkane, I will write here. If it is alkane, you add the section ane. So for example, it is a propane. If it is alkene, you add the section ene. So it is a propene. Okay. If it is alkyne, you add the section ine. So it is a propine. Okay, you add the section I. So I have methane only. I don't have methane or methane for sure. I have ethane, ethene, ethine. Propane, propene, propine. Okay? Butane, butene, butine. And then I have bentane, bentene, bentine. Hexane, hexene, hexine. Heptane, heptene, heptine. Octane, octene, octine. Nonane, nonine, nonine. Decane, decene, decine, and so on. Really easy, right? This is how to name the hydrocarbons in general. Now, I want to tell you that for each hydrocarbon, whether it was alkane, alkene, or alkyne, you have to know that I have the structure of the hydrocarbon, and I have structural formula and molecular formula. This is really important. How to differentiate between them? For example, I have methane, which contains only one carbon. So the structure of the methane is as written here. C with 4 carbon, because you have H2N plus 2. So I have 4 hydrogens. Okay, I have 4 hydrogens. I draw it like this, which is the structure formula. Actually, it shows the number of elements, the type of elements, and the type of bonds. If you can see here, I can clearly see that I have all single bond, hydrogen, and carbon. The structural formula actually gives you only number and type of number and type of atoms. But in this structural formula doesn't show exactly the type of bonding, because you cannot see here the double bond or triple bond. Because, in the molecular formula, you don't see the double bond or triple bond, but in the structural formula, it is easy to know the type of the bond, which is all double bond as seen here, and, all single bond as seen here. And we have a number of atoms. I have 1 carbon for hydrogens, and type of atoms, carbon and hydrogen. The molecular formula is like we write it in a simpler form, or let's say in a simplest form. Like we have no simplest form than CH4, so we wrote it CH4 as well. Now, ethane, that contains 2 carbon and it contains 6 hydrogens. So it is CH3, We write it in a structural formula in this way, CH3, and this is the formula that we use it to write chemical equations and to solve many different equations. And if I want to write it in molecular formula, I write C. How many C do I have? 2. How many hydrogen? 6. So it is C2H6. This is called molecular formula. Further chapters, we're going to learn that we have empirical formula as well. For the propane, we draw 3 carbons, and because all are single bond, we draw hydrogens around each the carbon to get 4 bond around the carbon. And then here I have CH3, if you can see here. And then I have CH2, as you can see here, and I have CH3, as you can see here, and we can write it in C3H8 form. I have butane, and so on. And please, you can do it as a homework. Write the structural formula and molecular formula for the other 5 carbons. Now, for example, if you have I told you here how to know the number of carbon and hydrogen numbers, which is CnH2n plus 2. We have already explained this before. And then we move to the alkenes. We explained that alkenes actually are hydrocarbons that contain double bond, and the hybridization is sp2, And then here I have the structural formula and molecular formula for specific alkenes. For example, I have ethene. Now F 2 carbons. So I say CnH2n. So I have only 2 carbons. So I will end with C2H2 times 2, 4. Which is C2H4, which is the molecular formula. And then when you go to the structure formula, you first draw the 2 carbon, and then you bind the 2 carbons with double bond as shown here. After this, you continue the bond, just to get sure that around each carbon atom there is 4 hydrogen bonds, okay, 4 hydrogen bonds. So I have 1, 2, 3, 4, and I can write it in a different way, which is a structural formula. I have CH2, double bond CH2. You can see here that the double bond is shown clearly. So the structural formula actually shows the double bond. So I can here clearly see the double bond and the molecular formula as well. I have the propane meth, ethprop. So I have 3 carbons. I will draw 3 carbons and then I'm gonna put the double bond here. After this, I have to get sure that all the carbons are octet. It means they have 4 bonds. For this carbon, 1, 2, 3, 4, I will fill with hydrogen. For this carbon, 1, 2, 3, so it needs only 1, 4. For this carbon, it contains 1, 2, 3, 4 carbon hydrogens. And then, teacher, we can summarize this into a structural formula, which is CH3, as you can see here. Then CH, as you can see here, double bond, CH2, as you can see here. Then we summarize it into C3H6. Let's take the butene, for example. How to draw the structural formula of a butene. Now, butene meth, ethprop-bute, I have 4 carbons. So I will draw 1, 2, 3, 4. And then I'm going to put the double bond either here or here. They're going to be isomers. I will draw it first here, for example, and then I will put the hydrogens in order to make sure all the carbons are surrounded by 4 bonds. Okay, for this carbon, I have only 1 bond. So I will put another 3 bonds. For this carbon, it has 2 bonds, as you can see here. I will put 2 bonds. For this carbon, it has 3. I will put only 1. For this carbon, it has only 2, so I will put another 2. So I end with CH2, as seen here, double bond, CH, then CH2, then CH3. This is the structural formula. And then we do a molecular formula, which is how many carbons, 4, how many hydrogens, 8, and so on. And then, teacher, you can put the double bond here. It's not the same. It's an isomer. But you can put it here. But the first double bond and the second double bond, if you put it here or there, it's going to be the same molecule, or let's say the same hydrocarbon. But if you put it inside here at the middle, it is another isomer of a butene that we are going to explain later on. Please continue doing the other 5 carbon atoms for the alkene. And then we said it's CnH2n only. Then we have, this is a repeated slide. Then we have, and this is another repeated slides. Okay, now here I have something really impressive that is got to see in the laboratory. I have a very important test to differentiate between alkane and alkene. Okay? Alkane and alkene. Now, consider that you are in the lab and you are given 2 test tubes with the hydrocarbon. The first one is alkane, the other one is alkene. And you went out for like 5 minutes, and when you came back, you noticed that these 2 test tubes are switched. How would you know which one is alkane, which one is alkene, since both have the same color, the same structure, and the same, let's say, smell, the same everything? And you didn't label the test tubes. There is a very famous test to identify whether this one was alkane and alkene, which is that you add a bromine. You add bromine, which is the bromination of the alkene. Now, when you add a bromine into these 2 beakers, the alkene, as I told you, is already saturated. It doesn't have double bond. There is no reaction with the bromine. It will not react with the bromine, and the color of the bromine is yellow-orange. Let's say orange. So when you add the bromine, the orange, into the alkane, it will stay orange, okay? It stays orange, it doesn't change because there is no reaction here, no reaction, because alkanes are saturated. They don't react with alkane, they only react with the chlorine by substitution reaction. We're gonna explain this later on. For the alkene, as it has a double bond, so when it is unsaturated, it likes so much to do reaction. It reacts with the bromine by addition reaction, yes, and or substitution reaction. We remove the double bond and we add the bromine, the Br2. We are going to explain this. So it turns into colorless. The colorless, when we see it's the colorless, so there is alkene. And then we explain the alkynes. As we said before, it has a triple bond, teacher. The first one is sigma, the other one is bi, the third one is bi. And one of the most important thing to know is the benzene ring. First, the benzene ring contains of 6 carbon, which is hexa, okay, and it is a closed cycle, so it is a cycle. It is aromatic, it means it has a smell. And if you can see here that I have 6 carbons and I have 3 double bonds. I have, this is the first double bond, the second double bond, the third double bond. And this double bond, or I can draw it in the other way. If you draw 6, 1, 2, 3, 4, 5, and 6. Each one of these edges is a carbon atom, teacher. Okay, this is called a cycle. And then we have 3 double bonds. I might put this double bond, the first one here, the other one here, the third one here, and then you continue adding the hydrogens to get full number of bonds. This carbon contains 1, 2, 3. See, so it only needs 1 hydrogen. This carbon contains 1, 2, 3 bond, it needs only 1 hydrogen. This carbon contains 1, 2, 3, so it needs only 1 hydrogen. The same for this, the same for this, the same for this. But actually, these double bonds can transfer, can move, okay? They are not fixed here and here and here. This double bond can move here, and this double bond can move here, and this double bond can move here. Can you please predict how to draw the other form of the benzene, or let's say the other isomer of the benzene, which is like this? I'm gonna write this here, and the other one is here, and the other one is here. Can you see? Because these 3 double bonds are in constant moving because I have isomers. These are called isomers. So in order to represent that the double bonds move consistently, so we draw it in this shape, the benzene layer, the benzene cycle, to illustrate that the double bond is in a constant movement. So what is isomer? It is, they are different compounds. They are different compounds, but they have the same molecular formula. They have the same number of carbons. They have the same number of the hydrogens, but they differ in the location of the double bond, in the arrangement of the carbons and double bonds. Do you remember at the first chapters previously, I gave you 3 important definitions and I asked you to think about them? They were isotopes, and isomers, and allotropes. And then we say that isotopes are the same element with the same atomic number, for example 17, but they differ in the atomic mass. For example, here I have 35 and here I have 36. This is the isotope. The allotropes, we say the same element with a different number of atoms, for example, O2 and O3. And then I told you that isomer is going to be explained in the chapter of organic chemistry, which is the same, different compounds, but they have the same molecular formula and the same number of carbons, same number of hydrogens, but they differ in the location of the double bond. The arrangement of the carbons makes isomers. Let's move to the next idea. And now let's move to the other idea. The other idea actually is the functional groups. The functional groups are hydrocarbons, yes, they are hydrocarbons, but they have more other things than carbon and hydrogens. They might have oxygen, they might have nitrogen, they might have halogens, one of the halides, which are fluorine, chlorine, bromine, iodine. Whenever you see a hydrocarbon that contains oxygen, contains nitrogen, contains halide, it is said to be the other functional groups of the hydrocarbons. Not only the hydrocarbons, only alkane or alkynes. There are many different functional groups which are widely used in our daily life, and it's very important. But cheer out. In your American high school diploma, you are only asked to know simple information about the functional group. In advanced level, you are going to go through by details into these functional groups. So what do we mean by functional groups? Let's have the first three functional groups in this video, and then I just don't want to make it very hard at the first time. We're gonna continue the other functional groups in the next video. The first one, which is as we said, alkane and alkyne all are given. We have now here the alcohols, okay? What are alcohols? Alcohols, teacher, are very easy. Alcohols, I'm going to open the whiteboard. Maybe you see this one, you got like shocked, what is it? No, it's so easy. Alcohol is a functional group. It contains of hydrocarbon. Whatever the hydrocarbon are, we represent the hydrocarbon by R. R means hydrocarbon, like number of carbon and hydrogen, and it has as well OH. The OH is the hydroxide. Okay, let's take an example. For example, CH3CH2OH. How did we write it? I will write 2 carbons, and I will provide this carbon with 1, 2, 3 hydrogen, and this carbon with 1, 2, 3 bond. But instead of hydrogen, I will put OH. This is only the difference, okay, teacher? Instead of the hydrogen, we only have an OH instead of the hydrogen. So we write C123CH3, and then I have C12CH2OH. This is alcohol. Of course, I have different type of alcohols. I have primary alcohol, secondary alcohol, tertiary alcohol, but it's not asked from you to know the type of alcohols. How to name the alcohols is only to take the number of carbons and you add the section all. For example, this is meth, F. So we say it is ethan. Okay, ethan, all. Okay, it is ethanol. So I have ethanol, methanol, propanol, butanol, and so on. You have only to take one hydrogen and instead you put OH. This is alcohol. Easy? Right. Let's move to the next one, which is ethers. Okay, ethers. The other one is the ether. When do we say that I have ether? When do we say that I have ether? Ether actually is so easy. You see, I will open here a new page and I will write here the ethers. Ethers. Ethers, what are ethers actually? Ethers is hydrocarbon that has R, which is CH, carbon and hydrogen, and another R, another carbon with hydrogen, and at the middle we have oxygen. Okay, we have oxygen. For example, I have CH3O, CH2, CH3. How did we write this? I will write, this is 1 carbon with 3 hydrogens, and I have here 1 carbon with 2 hydrogens, and here I have 1 carbon with 1, 2, 3 hydrogens. Between the 2 carbons here I have oxygen. This is called ether, CH3O, CH2, CH3. Okay? How do we name the ethers? We divide the ether into 2 parts, left and right. The left part, meth, so I have here meth, I have here ethyl. Okay, so it's ethyl because it is not full ethane, because I still have 1 missed hydrogen. It is not full ethane, so it is ethyl, like alkyl. Okay, ethyl. In the right side we have ethyl. On the left side we have 1 carbon, which is meth. Okay, so, and it is methyl. So ethyl, methyl, and then we add the last section, ether. Ethyl, methyl, ether. So I know that I have oxygen, I have ethyl, and I have methyl. So ethyl, methyl, ether. And why do we start by ethyl, teacher? Because we start, this is E, ethyl, and this is M, methyl. We start by the alphabetic arrangement. E comes before the M, so we say ethyl, methyl, ether. This is the other functional group. The third functional group with us will come on stage as the aldehyde and ketones are sisters. Actually, I can't separate them. The aldehyde and ketones are very good friends. They love each other so much. They are similar in some reactions. I mean, they undergo some same specific reactions. Whenever we study, we say all the time, aldehyde and ketones. Okay, aldehyde and ketones, like carboxylic acid and esters. So aldehyde and ketones are very good friends, so we have to study aldehyde and ketones together, and then that's enough for this video. Now, what is aldehyde and what is ketone and what is the functional group? See, teacher, concentrate. I'm going to write here the aldehyde and ketone. I'm going to write here the aldehyde and ketone. You have to concentrate. I have here aldehyde. Okay, let me separate them. The friends are aldehyde and ketone. They are similar with the functional group, which is carbonyl, teacher. They are similar with the functional group, which is the carbonyl. The carbonyl functional group is C double bond O. C double bond O. This is called carbonyl. Okay, this is called carbonyl, the functional group, the main functional group. So the aldehyde, teacher, is any R, any CH, carbon with hydrogen, that ends with C double bond O, and after the C double bond O we have hydrogen. Okay, if you can see here, C double bond O, that can have only hydrogen, and the aldehyde functional group always come at the end. It is a terminal functional group, like it cannot be on the middle, because it cannot be, or you cannot have other things after the hydrogen, because hydrogen cannot bond with more than 2 electrons. Now, for the ketone, the ketone is her friend. It has an R, which is the carbon and hydrogen, the C double bond O functional group, which is the carbonyl, but after the C double bond, I end here with H. For the ketone, I end here with another R. Let us have examples. You see the difference? This is aldehyde and this is ketone. Let us take example. For example, I have CH3, CH2, and then I have C double bond OH. Let me write it in a structural formula. I have 1, 2, 3 carbon. The first carbon, I will fill it with hydrogen ordinary. okay? But the other one must be the functional group, which is double bond and hydrogen. This is the functional group. This is the thing that actually is different than other hydrocarbons. For the ketone, I will put the same number of carbons, which are 3. Okay, I will see here I have CH3, and then I have C double bond O, and after the C double bond O, I have another CH3. If we write it in structural formula, I have CCC. This double bond O, and all the carbons, this is the functional group, and all the carbons must be filled ordinary with hydrogens. I have here 1, 2, 3 hydrogen, and I have here 1, 2, 3 hydrogen. If you notice, this is the something that makes it different, the functional group, which is here the carbonyl group. So I have here the carbonyl group that has hydrogen after it, which is aldehyde, but the carbonyl group, when it has another carbon after it, it is ketone. If you notice that the aldehyde, the carbonyl group, cannot be in the middle because it has hydrogen at the end, which is terminal atom, because I can't bind something next to the hydrogen. But for the ketone, the C double bond O, it must be in the center. It must be in the middle, okay? Because after the C double bond O, I have carbon, and others at the C double bond O, I have, before the C double bond O, I have carbon. And again, the R, we represent R like we represent the carbon and hydrogen. Last thing is how to name aldehyde and ketone. Aldehyde, we take the number of carbons as usual, and we add the section al. Okay, for example, I have 1, 2, 3 carbons, so I say meth, prob. So this is propan, general, but it is not a propan alkane, it's a propanal. Okay, it is a propanal. This is how do we name the aldehyde. So I have butanal, ethanal, methanal, butanal, propanal, pentanal, hexanal. You can add many different number of carbons. If I were you, I will open my notebook and I will do a table like this. Okay, teacher? And I will write the number of carbons here. For example, 1, 2, 3, 4. And I will write here the aldehyde. Okay, the aldehyde, I will draw it by drawing like this. And then I'm going to write it in a structural formula, and I'm going to name it. By this, I will practice more and more regarding this chapter. For the ketone, we take the number of carbons and we only add the section on. We only add the section on, which is 1, 2, 3. Meth, prob. You see, if you don't know the number of carbons name, only you will be lost. Like meth, you don't know that 3 is a prob. Meth, prob. For example, if you name this like hexanone or whatever, you would get mistakes. So it is really important. The first step in this chapter is only teacher to what? To take the number of carbon names. So I have 1, 2, 3, meth, prob. So I take the number of carbons and I add the section on. So meth, prob, this is a propanone. Okay, this is a propanone. So after adding propanone, this is a ketone. So these are the friends, which is aldehyde and ketone. Going back to the previous one, I have the alcohol. Alcohol, it has actually it has an OH, which is the hydroxide. I take the number of carbons and I add all, like methanol, butanol, heptanol, hexanol, and you can put this OH in any position of the hydrogens. It can be here, it can be here, it can be here, here, whatever. So I have a primary alcohol, secondary and tertiary alcohol. And then we have the ethers. The ethers are two carbons, but in the middle I have only oxygen. For example, CH3O, CH2, CH3. I have here only one oxygen. So how to name this ether? That I take each side and I name each side like alkyl, like methyl, propyl, butyl, pentyl, and so on. And then I have here methyl, and here I have ethyl. I start with the alphabet, then I say ethyl, methyl, and then I add the word ether. And then we have next, we explain the friends which are aldehyde and ketones. If you remember previously, that aldehyde are C double bond O, which is the carbonyl group with the hydrogen, and the ketone is C double bond O, the carbonyl group with another carbon next to the carbonyl. Here, it has to be terminal because I can't add something next to the hydrogen, and here it must be in the center because I have another carbon next to the C double bond O. And then I have teacher here, 1, 2, 3 carbons. How do we name it? By adding the section al, which is meth-eth-prob, so it is a propanal. And here, how do I name it? Is the add the section on. So I say meth-eth-prob, it is a propanone. So these are the first 4 functional groups we explained. We explained so far alkane, alkene, alkyne. We explained alcohol, ethers, and the 2 friends which are aldehyde and ketone. Wait us to the next video because we are going to explain more functional groups and we are going to go deep through into more functional groups and solve many different questions regarding this chapter. See you next time. Bye bye.